بسم الله. نبدأ بس بمراجعة بسيطة to refresh our memories of what we covered so far. So in Unit 1, we started with an introduction to the course, what we're going to learn throughout the course, and mainly how to write simple Verilog code to describe combination and logic circuits. So for example, if I have a circuit like this with three inputs A, B, and C, and output Y, and I want to describe this circuit in HDL. Let's call it, if you want to call the circuit AO اللي هي and OR. So we'll start saying module AO, that's the name of your circuit. And then here we can define the inputs and the output. We can say input A, B, and then output, we're missing one input, A, B, C, output Y. End module, and in between we will define our circuit. In this case, we'll use the assign statement. Assign Y is equal to A and B or C. So this is the HDL description of your circuit. بعد كده في Unit 2, we're still talking about additional logic design topics. Some of them we covered briefly in CEN212. Some of them we didn't cover before. So additional logic design topics. So far, we talked about timing and propagation delay. We talked about the propagation delay as how to measure it using TPHL and TPLH. And we said that the high to low transition and low to high transition, this is with respect to the output signal. And then we moved on to talking about the sequential circuits timing issues. We defined TS as the setup time, TH as the hold time, TPHL for the flip-flop, let's say TBD. The same rule applies for the TBD for the flip-flop. That's going to be the max of high to low transition or low to high transition. The propagation delay through the flip-flop, what we mean by that is the time for the input signal of the flip-flop to propagate to the output signal. If we have a D flip-flop, that means when the clock edge comes, if this is an edge triggered flip-flop, when the edge comes, how much time does it take for Q to take the value of D? We also had the T propagation delay, TBD, of the combination circuit. This is in a sequential circuit system. You're going to have a group of flip-flops and then another group of flip-flops here. In between, there will be some combination logic. So the worst case through the combination logic is going to be TBD combinational. We also talked about, we defined TP as the period of the clock, if you have a clock signal. So the time of the clock going 1 to 0 back to 1 again, this is TP. We also said that frequency is equal to 1 over TP, and frequency is measured in hertz. If I give you frequency, you need to convert to TP, so you can apply the equations. And then we moved on to talking about registers. We said register is just a group of flip-flops. So this is mainly a 2-bit register. So registers mainly are sequential circuits, and we can do the conventional state diagram and state table to define its function. But for a large number of registers, this is going to become infeasible. لذلك what we can do is we can take a small number of flip-flops and apply whatever function we want, and then we can expand to a larger number of flip-flops or a larger size register. على سبيل المثال اللي غطيناه so far اللي هو if I want a register with hold and load capabilities, we can take 1 bit register, which is essentially 1 flip-flop, and I need a signal called load, and let's define the function as if load equals 0, I want to hold the value of the flip-flop, and if load equal 1, I want Q to equal D. With a small truth table, you can find that we need a multiplexer at the input of the flip-flop. This is the clock signal, 0, 1, and the select line will be load. So if load equals 0, I want to hold, that means I'm rewriting the value of Q to the same flip-flop, so I have to route Q to the input 0. And for input 1, if I want to load the new data, I will apply it to data N, make load equal 1. That means on the next clock cycle, it will read, the flip-flop will read the value of Dn. Now this is for 1-bit register. If I want 3-bit or 4-bit register, all I need to do is to replicate this design. So let's say for a 3-bit register, I'll have 3 flip-flops. I will have 3 multiplexers. All of them are connected to the same signal, which is load, because we're dealing with the register as one entity. So you either load the whole register or you hold the value of all registers. Now each input 0 will connect to its own queue. And then the data N should be D0, D1, D2. This will make the output as Q0, Q1, and Q2. And of course, you will apply the same clock signal to all your flip-flops. What are we missing? This is connected to D. This is the 3-bit register from the inside. From the outside, we can deal with it as, we can draw it as a symbol like this. You can say Q0, Q1, Q2. This is D0, D1, D2. And we need 3 more signals, which is clock, the signal load, and signal reset, which we didn't show here, ولكن لازم يكون في reset for reset أو set أو both. Depends on your application. So this is equal to this. طيب في أي سؤال عن الماتيريال اللي غطيناه so far؟ الباوربوينت واضح؟ ظهر في الشير؟
واضح.
تمام. طيب did we stop here? Yep. Okay, so this is the design of a 2-bit register. As we saw, this is mainly a multiplexer. You can replace this whole diagram with a 2-to-1 multiplexer. I think it's easier to see than the whole circuit. طيب. We stopped at register notation. الآن يعني to make an analogy between HDL and other programming languages, we said that a register, it's mainly the variable of, or it acts like the variable of programming languages. In programming languages, when you want to transfer data, you want to do any operation, you need to define a variable, like integer x, for example. You define integer x, integer y, and then you can do all sorts of operation on these variables. You load the value of x, you load the value of y, and then you can define another integer, let's say z. This is equal to x plus y, and so on. For HDL, we will deal with registers. So, to denote a register, you need to have a combination. You can use a combination of letters and number. For example, register R2, register PC, register IR, any name can fit for your register. Now, these registers have sizes. كان عندنا في programming languages we have to define a type. هنا we only have يعني a register is just a set of flip-flops, but it should also have a size. So if R is an 8-bit register, and let's say, for example, I want to read only 3 bits or 2 or 4 bits out of R, I can use parentheses to define a range of bits that I want to read. If I want to read a single bit of R, or in this example, register R1, if I say R1 open parenthesis 1, that means I need to read 1 bit of R1, which is at position 1. طبعا note that we start at position 0, just like an array in programming. It starts from 0 up to n-1. I can also read a range. For example, register PC here. PC is a 16-bit register. If I want to read only the first 8-bit, I can use the colon. So this will read bits 0 to 7. طبعا تكتب بالعكس. ما ادري اذا استخدمتوا بايثون او ماتلاب، ولكن in Python and MATLAB you can define the range. For example, إذا عندك array size 15 and you want to read the first 8 entries, you can say array 0 أو قوس حسب اللغة 0 to 7. This will read array of 0, array of 1, array of 2 up to array of 7. بالنسبة لل HDL لا، حنكتبه بالعكس. السبب إنه this will be the most significant and this will be the least significant. Remember that we are dealing only with binary. Also, L can be defined as a number. You can put a variable between parentheses to read a certain يعني بالنسبة ل PC 7 to 0 and PCL هنا to be the same. لأنه هنا I defined PC as one 16-bit register ولكن قسمته إلى 2 registers, which is PCL and PC high. Usually when you do that, you mean PC high and PC low. The higher position bits of PC and the lower position bit of PC. طيب, we also have an arrow. طبعا كل هذه اللي بنتكلم عنها هنا هي تشبه كتابة الالجوريثم. هذه ما لها علاقة بال HDL syntax. HDL syntax, we'll talk about it later, but to define the operation of your code, you need to first write, يعني بالنسبة للprogramming language, you write an algorithm. You can say يعني for example هنا هذا الآن code in Java, ولكن قبلها المفترض يكون فيه description of your code, which is the algorithm. I will say load x with value 2, load y with value 3, let z be x plus y مثلا. هذه الآن هي algorithm. It's a text description of your program. نفس الشيء هنا. To define the flow of data in your system, to write the HDL code, we will use يعني these notations. فبالنسبة للارrow when I write something like this R1 arrow this side R2, that means load R1 with the value of R2. So it will read whatever in R2 and it will load it to R1. Same, we can use the parentheses, load the lower half of register PC with the value of R0. طيب لاحظ انه هنا غطيناها لكن هنا كان في كوما. كوما will separate parallel operation. يعني at the same clock cycle I want to do two operations. I want to load R1 with the value of R2 and I want to load PC low with the value of R0. Then later when we talk about memories, we will have to use brackets. The bracket will denote the address of the memory we're accessing. A memory is basically a storage unit that looks like this. خلينا نقول this is 4 bits and you only have 1, 2, 3, 4, 5 entries. So you need an address for each entry. So this is 000, 001, 010, 011, and 100. This is the address and this is the data. So for example, if I want to load the register R0 with the content of memory, let's say address 2, يعني الداتا اللي هنا I want to take it and load it into register R1. خلينا نقول مثلا we can write R1 will take the value of the memory. طبعا اسم الميموري عندك لازم يكون في variable محدد باسم الميموري. We will say M of 010. Or we can define another register called add, means address, and I can assign it the value 010. So I can write R1 will take the value on memory at the given address. So between brackets, you either you either enter the address or you can use a variable to, or you can read the address out of another register. طيب notation عندنا notation مهم جدا اللي هو conditional transfer. Conditional transfer means if I have another register called K1, it's a 1-bit register. If K1 equal to 1, I want to load R2 with the value of R1. How to write this in description? I will say K1 colon and then whatever I want to do. So let's say R0 will take the value of R2. What it means that if K1 is equal to 1, do this operation. If K1 is equal to 0, just ignore this line. So this is called conditional transfer. Basically, we will learn how to implement this, or how this conditional transfer is occurring in hardware, which is basically how your if statement in your Java or in your C is translated into hardware, how it's really done on hardware. But for now, we just need to know the notation, which looks like this. So a semicolon will evaluate a Boolean function at this side. If it turns out to be true, I will execute whatever on the right side. طيب. Now we move on to talk about micro operations. We have 4 main kinds of micro operation that we can do on registers. First and the simplest is called transfer. Transfer mean we will move data from one register to another, just like we did in the previous example. When I write this notations mean load the value of R1, load the value of R2 into R1. As a micro operation, this is a transfer. We will transfer the data from R2 and we will save it in R1. We also have arithmetic operations. this will perform arithmetic on data and registers, which is basically the addition, subtraction, multiplication, and division. I'm not sure, but maybe we can have also a module operation. Module operation will return the remainder of a division operation. So 4 over 2, مش 4 over 2, let's say 5 over 2. 5 over 2 will equal to 4, and we will have a remainder of 1. So if I write 5 modulo 2, the result of this operation should be 1. I'm not sure if it exists in HDL, ولكن this is one very well-known arithmetic operation. طيب, other than arithmetic operation, we can implement logic operation because we're working with binary. The logical operation that we know of, it's the OR. The symbol for OR is this one. أعتقد هذه السيمبلز نفسها اللي استخدمتوها في Math 151. So in your text description of your circuit, we will use these symbols. So we have the OR, we have the AND, we have the XOR, and we have the NOT. That's why we can have all the other logical operation, like if you want to apply an OR or an AND, that's going to be easy, because if you have A and B, if you take the complement of this operation, that's going to be an AND gate. For example, if you want an XNOR gate, you will take the complement of an XOR operation. طيب. Last operation is called shift. We will talk about shift maybe today, or usually today, but maybe in this lecture أو lecture القادمة إن شاء الله. Shift means that I will shift the data in my register either right or left. مثلا, if I have 1101 in a register and I defined an operation, I say shift, let's say this is called R1. That's register R1, and I want to shift R1 to the left مثلا. The result of shifting this value to the left will be 1010. ليش? It's like I'm adding a 0 from this side and I'm pushing it into the register. This is a 4-bit register, so it will contain only 4 bits. So shift left is going to add this 0 to your register, and it will remove the most significant bit you have. This will be thrown out. This is the shift operation. There are many kinds of shifts, ولكن in general we will talk about shifting in details. ولكن as micro operations that can be performed on your registers, these are the operation. You can transfer, you can do arithmetic, you can do logic operation, and you can do shifting operations. Example of some micro operations. We can add the content of 2 registers and save the result in another register. So here I'm saying take the content of register R1, add it to the content of register R2, and feed the result back to register R1. If you want to visualize this in hardware, that means I have an adder that takes in 2 values, A, B, and I'll have sum at the end. So I will connect R1 here, and I'll connect R2 here, and the sum I will connect R1. طبعا هنا R1 we will read from it, and then we will write the value to R1. طيب, we can also multiply. So take the content of register R1, multiply it by the content of register R6, and then save the result in register PC. Logical operation will be the same. Take the content of R1, XOR it with the content of R2, and then save it to register R1. بالنسبة للvalues طبعا it's just like programming. When I define x as 1, y as 2, and then I say x is equal to x plus y, what is the value of x here?
1.
1. After this operation إذا استخدمت x مرة ثانية هنا مثلا print x, if I print x after this operation it's gonna be 3. If I print x here that's gonna be 1. نفس الشيء هنا. This will take the previous value of R1 or whatever was stored in R1, XOR it with R2, and then save it to R1 again. So if you use R1, if I want to load R2 with R1, I'm going to take the value that was XORed with R2 here. If you define this as a parallel operation with a comma, let's say R1 takes R1 XOR R2, and R3 takes R1. In this line, the value of R1 will be the old value of R1. It's not going to be the value that is XORed with R2, because these are parallel operation. Parallel operation معناته it's happening at the same time. So R1 still did not get the new value after this operation. طيب, more examples. If I write PC takes the value of R2 bar, that means I will complement R2 and store it in PC. The value of R2 is not going to change. This is an operation that will be applied to R2 and then passed on PC. فإذا R2 كانت تساوي 1010, after this operation, the value of PC will be 0101. The value of R2 will stay the same because I just used it as a source. In hardware, what it means that I connected each bit of R2. If this is the R2 register, I connected all these to an inverter, each bit, and then I loaded the value, the output of the inverter into register PC. So the value of R2 stays the same. It's not going to be inverted. طبعا هذه complement اللي هي تعتبر ones complement of R2. So the complement will apply the ones complement, not the twos complement. If you remember, we had ones complement and twos complement. Ones complement is just flipping all the bits, which means inverting each bit. Twos complement كان شيء ثاني. طيب, بالنسبة للcondition, a condition can be a single bit register. In the previous example, it was K1. ولكن I can define a function at the condition which will evaluate either true or false, and depending on the evaluation we will apply whatever operation we have. فمثلا in this example, K1 or K2 colon R1 will take the value of R1 or R3. So first I need to evaluate K1 or K2. If this is 1, we will apply this operation, which is a logical operation AND. If this evaluates to 0, it means we will ignore this line. طبعا المهم أو شيء لازم تنتبه له إنه in this side في الoperation إذا استخدمنا هنا plus sign negative sign خلينا نقول plus sign. Plus sign this means addition. هنا on the left side at the condition, no, this means or. لأنه the result of the condition has to be a single bit with a logical value of 1 or 0. يعني this has to evaluate to true or false. هنا لا، هذه حتكون addition, you'll just add two numbers and then load it to R1 or any logical operation. For example, this is the OR operation. طيب في أي أسئلة so far؟ Okay. طيب we'll talk more about the control expression. So we said the control expression can be a function. Let's say, for example, you have two control signals, which is K1 and X. And K1, as a definition, K1 will be the enable signal of your adder or of your add subtract unit. Signal X will decide if this is an add operation or a subtract operation. K1 is the enable for the whole unit, and X will define which operation you want. فبالتالي if K1 is equal to 0, K1 is equal to 0 معناته no operation. If K1 is equal to 1, I have to read X. If X equal to 0 في هذا المثال X equal to 0 معناته I want to add. If X equal to 1, I want to subtract. طيب, as a notation, we can write X bar K1. That means when X equal to 0 and K1 equal to 1, that means if the add unit is active and I want to do an add operation, so take the value of R1, add it to the value of R2, and then save the result to register R1. Now, if I want to subtract, which is R1 minus R2, and load it into, let's say, R1, what's the condition? K1 has to be 1 and X has to be 1. That means enable the adder, and we want to do a subtraction. طيب, I can either write it this way, R1 minus R2, ولكن in actual implementation, how do you subtract two numbers from each other? We studied this in CEN212. We said if I have A minus B, what you can do is make it A plus the 2's complement of B. Because what we created is an adder. We had a full adder, we created the full adder in hardware. We also looked at full adder in Unit 1. طيب, how do I get the 2's complement of B? This will become A plus the 1's complement of B, and I will add 1. How do I get the 1's complement of B? This is just B bar, which is inverting all the bits in B. فنرجع للoperation اللي هو if K1 equal 1 and X equal 1, I want to subtract. That means I can write it as R1 takes the value of R1 plus R2 bar plus 1. This is the 1's complement. واضح يا شباب؟
واضح.
طيب. What you need to remember is that this side is evaluating a Boolean expression and has to be at the end a single bit 1 or 0, which will decide if this operation should occur or not. طيب. This table is a summary of all the arithmetic micro operation that you can do on registers. So for addition, we'll use the plus sign. For complement, we will have the bar. If you want the 2's complement, that's R1 bar plus 1, which is 1's complement plus 1. If you want to subtract two numbers, that means you will take the first number, you will add it to the 2's complement of the second number. And then R plus 1 or R minus 1, this is a decrementer. Either an increment or a decrement, which will either count up or count down. One more thing, these registers in their position have names. So R0 here is a destination register. R1 is called source 1, R2 is called source 2. طبعا كتابة لما أقول R0 takes R1 or R1 plus R2 أو R0 takes R2 plus R1. في النهاية, as a result, at the end of the operation, it's going to be the same. The addition of these two registers, of the content of these two registers, will become at R0. ولكن يفرق عندك هنا في الهاردوير. When you implement this operation, you need to decide what is the source, what is source 1 and what is source 2. So طبعا any register in your system can be defined, can be used as a destination or can be used at any of the two sources. So again, naming, destination register, source 1 and source 2. طبعا هنا constant, ولكن if it was a register, that's source 1 and that's source 2. This is for all the arithmetic micro operation we have. بالنسبة للlogical micro operation and how we write them, this is the complement, which is the bitwise NUT. It's the same as the 1's complement. Bitwise OR is written as this. طبعا ايش يعني bitwise OR؟ يعني if R1 is equal to 1001 and R2 is equal to 0100, the result of the bitwise OR of R1 and R2, bitwise يعني we'll take it bit by bit. So you need 4 2-input OR gate to do this in hardware. So this is 1 or 0 will become 1, this will become 0, this will become 1, and this will become 1. So we will store this value in R0. طيب بالنسبة للAND, the same. This is gonna be operating bitwise fashion, the same. We'll take it bit by bit and we will add them together. And then we have bitwise XOR. طبعا كاستخدام كيف نقدر نستخدم الOR والAND والXOR? The OR will be used to set certain bits in your register. خلينا أقول R1 هو التارجت register تبعي. خلينا أقول R1 have certain bits. If I want to set the value of this bit as 1 and this bit as 1, regardless إيش كان، ما يهمني إيش كان. الفكرة إني أبغى R1, I want to set these two values to 1. What I do, I go to R2, I load the value of 0110, and then I'll use R1 or R2, and then I store it anywhere. ما يهم. اللي حيصير, the result will be a copy of R1, ولكن with these two bits as ones. If I want to clear certain bits of register R1, I will use R2 as a mask with zeros at wherever I want to set. Let's say I want to reset the value of bit This is bit 0, bit 1, bit 2, bit 3. I want to reset the value of bit 2 and the value of bit 1. So I will load R2 as 1001. I'll take this and I'll AND it with register R1. What's the result? It's going to be 0, 0 here. وهذه, these two will become whatever it was before. An XOR can be used to complement bits. If I want to complement, خلينا على نفس ال 2 bits اللي هي 2 and 1. We know that X XOR 1 equal to X bar. And X XOR 0 will equal to X. فبالتالي if I want to complement bit 1 and bit 2 in R1, I will load R2 with the value of 0, 1, 1, 0 and XOR that with R1. الناتج هيطلع عندي كالتالي 1 2 3 4. This bit will be complemented, this bit will be complemented, and these two will stay the same as it was before the operation. تمام. If you want to set some bits, we can use R2 as a mask. We can load it with the value of, if you want to set certain bits, you load R2 accordingly. Same for clearing your bits or complementing certain bits. طيب, example for the logical operation. Let's say R1 equal to this value, R2 equal to that value, and then we will have R0 as the destination in all of these operations. ففي الجدول, this is the value of R0 after the operation has been executed. So if R0 equal to the complement of R1, we will take R1 and complement each bit. That will become 0, 1, 0, 1, 0, 1, 0, 1. If I want to OR R1 with R2, take the result. 0 or 0 will be 0, 1 or 0 will be 1. This will be 0, it's going to be 1, 1, 1, 1, 1. فبالتالي R0 will be all ones and then 0, 1, 0 at the end. Now if you want to AND these two together, أول 4 أصفار, this will become 4 zeros. Last 4 we have ones here, معناته these will become 0, 1, 0, 1. For the result of R0 will be 1, 0, 1, the rest are zeros. If you want to XOR 1, 0, 1, 0, 1, 0, 1, 0, XOR it with 1, 1, 1, 1, 0, 0, 0, 0. You can either go bit by bit, or you can consider R0 as a mask. So these 4 bits will stay the same. So that's 1, 0, 1, 0. And these 4 bits will complement whatever we have at R1. This should become 1, 0, 1, 0. And this is the result of XORing R1 and R2. We save it in R0. This will make R0 as this value. طيب, أي سؤال عن arithmetic operation, logical operation so far؟
عندي سؤال يا دكتور.
تفضل.
سلايد 27 اللي فوق يا دكتور اللي كتبتها أنت.
هذه؟
أيوة ما فهمت أنا بس وتعيد شرحها.
طيب, هذه اللي بحاول أقوله إنه إن let's say you have R0 takes the value of R1 plus R2. تمام. And R0 another operation takes the value of R2 plus R1. As a result after executing this operation أو this operation في النهاية the value of R0 will be the same. صحيح؟ لأنه I'm adding 2 numbers R1 and R2. في النهاية the result will be the same as this operation. لكن بتكلم in hardware, when you implement this in hardware, طبعا هذه كلها description of what your circuit does. فعندك انت السيركت, طبعا هذه this will be fed to an adder circuit. تمام. It should look like this. هنا عندك register، هنا عندك register، وهنا عندك register for the output. طيب هذا حيعتبر source 1 وهذا يعتبر source 2. This is destination. في النهاية بتكلم عن result of the operation will be the same لأنه R1 plus R2 equal to R2 plus R1 ما راح تفرق. ولكن in your hardware the first operation this will read from R1 and this will read from R2 and this will save in R0. هذه الأولى. الثانية حتكون مختلفة. الثانية I will load source 1 with R2 and I will load source 2 with R1. فهي ما هي زي الكومبايلر في طبعا انت لما تكتب في البرمجه مثلا you run the code او you compile the code في النهايه يعني ممكن يغير لك في الكود شويه على اساس انه كيف يسهل عمليه اللودينج والسيف والستورينج. في ال HDL لا it will follow exactly what you are writing. So if you write this code source 1 of your adder will take in the value of R1 and source 2 will take in the value of R2. This code source 1 will take R2 and source 1 will take and source 2 will take R1. الناتج نفسه R0 will be the same. بس أنا بتكلم إنه when you design the hardware that will load these two registers هيكون عندك hardware معين. الهاردوير هذا is connected to all your registers. هيكون عندك حاجة يسموها register file. يعني يمكن ما أدري حنتكلم عنها في هذا الكورس أو لا، ولكن 316 you'll definitely build something called the register file. هذا الريجستر فايل فيه له جميع الريجستر that you have in your system. ف there should be some logic circuit here that can read these values. For the way you read source 1 and the way you read source 2 will be different. يعتمد على how you يعني كيف ترتب these two registers in your operation.
واضح يا دكتور.
تمام. طيب before we close يعني before we end a few times shift. طيب we will start shifting إن شاء الله next class اليوم، ولكن I can cover this slide اللي هي المالتيبلكسر based transfer. طبعا شفنا هذه الاوبريشن اللي هي if k1 equal to 1 load the value of r1 to r0 and if k2 and k1 bar equal to 1 load the value of r2 in r0. فإن hardware how do we do that؟ عندنا السؤال destination هو r0 وهذه اللي هنا it's controlling the load signal. فبالتالي for this operation if k1 is equal to 1 load will be 1. في نفس الوقت what am I loading? In this case I'm loading r1. I can connect r1 and r2 into a multiplexer. هذه r1 وهذه r2. I connect the output of them to a multiplexer. هذا المultiplexer will choose r1 إذا كان k1 equal to 1. So I can take k1 and use it for the select line of the multiplexer. So if k1 equal to 1, I will take the value of r1. فبالتالي this will be r1. في نفس الوقت I want to load. فعندك اللود equal 1 وعندك r1 at the input. At the end r0 will take in the value of r1. If k1 equals 0, أساساً we will not choose r1. فبالتالي this operation will not occur. طيب في نفس الوقت إذا k1 equals 0 and k2 equal 1, I want to load the value of r2 into r0. بالتالي if k2 is equal to 1, that means out of this OR the load will be 1. طيب what's the value I'm loading? we need to look at this multiplexer. K1 equal to 0. بالتالي I will choose this input which is reading from R2. فبالتالي this will be R2, this will be R2, and load is 1. So I will load the value of R2 into R0 if I have this combination اللي هي K2 K1 bar. If I have K1 bar, K1 bar will choose R2 to pass through the multiplexer and become here. ولكن إذا K2 equals 0 هيكون عندي هنا 0 0 result of the OR is 0, so it will not load. بالتالي using this circuit, the simple circuit, I implemented the conditional transfer on registers. طبعا لا تنسى إنه هذا كله connected to clock, and we probably have some other input for reset. طيب إن شاء الله next class اليوم we will talk about shifting in details, how to implement shift registers, and probably we can start maybe not counters ولكن we'll see how it goes, ولكن we'll start إن شاء الله with shift micro operation next class today at 2 إن شاء الله.